Imagine standing outside on a clear night, far from city lights, gazing up at the sky. The stars seem endless, scattered across the darkness like diamonds on velvet. For centuries, humans have looked up and wondered, how big is the universe, really? How far do those stars go? What lies beyond the faintest point of light our eyes can see? For most of history, the answers were limited by the power of our imagination and the reach of our telescopes. But now, with the launch of the James Webb Space Telescope, we are finally beginning to glimpse the true scale of the universe, and what we're finding is more staggering, more humbling, and more mysterious than anyone ever expected. The James Webb Space Telescope, or JWST, is not just another observatory. It's a time machine, a cosmic archaeologist, and a window into the deepest reaches of space and time. Launched in December 2021, Webb was designed to see farther than any telescope before it, peering back to the very first galaxies that formed after the Big Bang. Its golden mirrors, spanning over 21 feet across, are tuned to capture the faintest whispers of infrared light, light that has traveled for billions of years, stretched and reddened by the expansion of the universe itself. With every image it sends back, Webb is rewriting our understanding of the cosmos, shattering old assumptions, and revealing a universe that is far larger, more complex, and more dynamic than we ever imagined. But what does it mean to talk about the scale of the universe? For most people, the numbers are so large they lose all meaning. A million, a billion, a trillion, these are words we use, but can barely comprehend. The observable universe, the part we can see, is about 93 billion light years across. That's not a typo. Even though the universe is only 8 billion years old, the relentless expansion of space means that the most distant galaxies are now much farther away than the age of the universe would suggest. Light from those galaxies began its journey when the cosmos was young, but as it traveled, space itself stretched, carrying those galaxies ever farther from us. The result is a universe whose true scale defies intuition, a cosmos where distances are measured not in miles or kilometers, but in the time it takes for light, the fastest thing in existence, to cross the void. Before Webb, our best tool for exploring the distant universe was the Hubble Space Telescope. Hubble's deep field images, painstakingly assembled over weeks of exposure, revealed thousands of galaxies in what appeared to be empty patches of sky. Each tiny speck was a galaxy, each galaxy home to billions or even trillions of stars. These images were revolutionary, but they were just the beginning. Hubble could see back to about 500 million years after the Big Bang, but beyond that, the light from the earliest galaxies was too faint, too redshifted, for its instruments to detect. The universe before that point, the so-called cosmic dark ages, remained hidden, a blank page in the story of creation. Enter James Webb. With its unprecedented sensitivity to infrared light, Webb can see through the cosmic fog, capturing the glow of galaxies that formed just a few 100 million years after the Big Bang. In its first year of operation, Webb shattered records, finding galaxies at redshifts of 13, 14, even 44, meaning their light began its journey less than 300 million years after the universe was born. These discoveries are not just numbers. They are windows into a time when the first stars ignited, when the first galaxies assembled, when the universe was still in its infancy. And with each new observation, the scale of the universe grows, both in space and in time. But Webb's revelations go beyond just finding distant galaxies. It's not just about how far we can see, but about how much is out there. In a single deep field image, covering a patch of sky no larger than a grain of sand held at arm's length, Webb found over 800,000 galaxies. Let that sink in a space so small you could block it with your fingertip. There are nearly 1 million galaxies, each one a vast island of stars, gas, dust, and dark matter. Multiply that by the number of such patches across the sky, and you arrive at a number so large it's almost meaningless. Over 2 trillion galaxies in the observable universe. 2 trillion. If you tried to count them all, naming one every second, it would take you over 63 years without stopping to sleep, eat, or breathe. And yet, even this is just the observable universe, the part we can see. Beyond that, the universe may go on forever, or it may curve back on itself in ways we can't yet imagine. The true scale of the cosmos may be infinite, or it may be bounded by laws and dimensions we have yet to discover. What Webb has shown us is that every time we think we've reached the edge, every time we believe we've found the limit, the universe reveals another layer, another horizon, another mystery waiting to be explored. But what does this mean for us, here on our small planet, orbiting an ordinary star in a typical galaxy? Why should we care about the scale of the universe, about galaxies billions of light years away, about the faint glow of ancient stars? The answer is both simple and profound, because the story of the universe is our story. The atoms in our bodies were forged in the hearts of stars that lived and died billions of years ago. The light we see from distant galaxies is a message from our cosmic ancestors, a record of the processes that made life possible. To understand the scale of the universe is to understand our place within it, to see ourselves not as isolated beings, but as part of a vast, interconnected tapestry that stretches across space and time. The James Webb Space Telescope's journey to reveal the true scale of the universe is not just a triumph of engineering, but a testament to human curiosity. Consider what it took to get here: decades of planning, billions of dollars, and the combined expertise of thousands of scientists and engineers from around the world. Webb's mirrors had to be folded like origami to fit inside a rocket, then unfurled with exquisite precision 1 million miles from Earth. Its instruments must be kept colder than Pluto, shielded from the sun by a 5-layer sunshield thinner than a human hair. Every detail, every calculation, every contingency was designed to give us a clearer view of the cosmos than ever before. And yet, for all this effort, the most astonishing thing is not the telescope itself, but what it has revealed. When Webb first opened its golden eyes, astronomers expected to see the faint afterglow of the earliest galaxies, small and dim, just beginning to form. Instead, they found something that defied expectations: galaxies that were already large, bright, and complex, existing just a few 100 million years after the Big Bang. These galaxies shouldn't have had enough time to grow so massive, to form so many stars, to assemble such intricate structures. The models said it was impossible, but the universe, as always, had other ideas. This is the first great contrast that Webb has brought into focus: the difference between what we thought we knew and what the universe actually is. For decades, cosmologists believed that galaxy formation was a slow, gradual process. Gas would collapse under gravity, stars would form, and over billions of years, galaxies would grow through mergers and accretion. But Webb's images show that the early universe was a place of frenetic activity, where galaxies sprang into existence with astonishing speed, where black holes grew to monstrous sizes in record time, and where the rules we thought governed cosmic evolution were being broken at every turn. Take, for example, the discovery of little red dots, compact, intensely bright galaxies that appear in Webb's deep field images. These objects are so small and so luminous that, by all rights, they shouldn't exist. Their stars are packed together so tightly that they would collide and merge constantly, something we don't see in any galaxy today. Some of these little red dots contain black holes that outweigh all the stars in the galaxy combined, flipping the usual relationship between galaxies and their central black holes on its head. In the modern universe, black holes are tiny compared to their host galaxies. In the early universe, it seems, black holes sometimes came first. This inversion of expectations is a recurring theme in Webb's discoveries. The telescope has found black holes feeding at rates far beyond what physics says should be possible, growing millions of times faster than the so-called Eddington limit. It has found galaxies forming stars at rates 100 times higher than predicted, lighting up the cosmos in a burst of creation that challenges every model we have. It has found evidence of massive structures, clusters, and filaments of galaxies, already taking shape when the universe was less than 1 billion years old, long before there should have been enough time for gravity to pull them together. Each of these discoveries forces scientists to rethink the fundamental laws that govern the universe. Are our models of dark matter and dark energy incomplete? Are there new forces or particles at work in the early cosmos? Did the first stars and galaxies form in ways we haven't yet imagined? Webb doesn't just answer questions, it multiplies them, opening new frontiers of inquiry with every image it sends back. But perhaps the most profound revelation is not just the scale of the universe in space, but in time. When we look at Webb's images, we are not seeing the universe as it is now, but as it was billions of years ago. The light from the most distant galaxies began its journey before Earth even existed, before the Sun was born, before the Milky Way had taken shape. Every photon captured by Webb is a messenger from the past, a record of events that happened when the universe was young and wild and full of possibility. This realization changes the way we think about our place in the cosmos. We are not just observers looking out at a static universe. We are participants in a grand story, connected by the flow of time and the exchange of energy and matter. The atoms in our bodies were once part of ancient stars, forged in the crucible of supernova and scattered across space by cosmic winds. The light we see from distant galaxies is a glimpse into our own origins, a reminder that we are made of the same stuff as the stars. Webb's discoveries also highlight the fragility and uniqueness of our moment in cosmic history. The universe today is calm and structured, with galaxies and stars and planets arranged in vast, elegant patterns. But it was not always so. The early universe was chaotic, violent, and unpredictable, a place where the rules were still being written, where the future was uncertain, and where the seeds of everything we see today were just beginning to sprout. To understand the true scale of the universe is to appreciate the improbability of our own existence, the delicate balance of forces that made life possible, and the fleeting nature of our time. Under the stars, the James Webb Space Telescope's revelations have not only expanded our sense of scale, but have also deepened the mystery of how the universe came to be so vast, so quickly. To truly grasp what Webb has uncovered, we need to step back and consider the journey of light itself. Every image Webb captures is a tapestry woven from photons that have traveled for billions of years, crossing the expanding fabric of space. These photons are not just snapshots, they are time capsules, carrying with them the story of the universe's earliest moments. When Webb peers into the darkness, it is not just looking far away, it is looking back in time, to an era when the first stars and galaxies were just beginning to shine. This concept, known as look-back time, is one of the most mind-bending aspects of modern astronomy. When you gaze at the Andromeda Galaxy through a backyard telescope, you are seeing it as it was over 2 million years ago. When Webb observes a galaxy at a redshift of 14, it is seeing light that left its source just 2 180 million years after the Big Bang. The farther we look, the further back in time we go, until we reach the edge of the observable universe, the cosmic horizon, beyond which light has not had enough time to reach us since the beginning of everything. But the universe is not static. As light travels, space itself expands, stretching the wavelengths and shifting them into the infrared. This is why Webb was designed to see in infrared. The most ancient light, the glow of the first galaxies, has been stretched so much that it is invisible to our eyes and to telescopes like Hubble. Webb's instruments are tuned to this faint, stretched light, allowing it to see farther and deeper than any observatory before. The result is a series of discoveries that have upended our understanding of cosmic history. For example, Webb's deep field surveys have revealed that the early universe was far more crowded and active than anyone predicted. Where models expected a handful of faint, primitive galaxies, Webb found hundreds, bright, massive, and already forming stars at a furious pace. The implication is clear. Galaxy formation began earlier and proceeded faster than our best theories allowed. The universe wasted no time in building complexity. This rapid assembly of structure is not limited to galaxies. Webb has also found evidence of massive black holes, millions or even billions of times the mass of our Sun, existing when the universe was less than a billion years old. According to standard models, black holes grow slowly, accreting matter over billions of years. Yet here they are, fully formed and voracious, breaking the speed limits set by physics. How did they get so big, so fast? Did they form from the collapse of gigantic clouds of gas, or from the deaths of the very first stars? Or is there a new, unknown process at work, one that only operated in the wild youth of the cosmos? These questions are not just academic. They strike at the heart of our understanding of how the universe works. If black holes and galaxies can grow faster than we thought, what else might be possible? Are there other cosmic phenomena waiting to be discovered, hidden in the faintest reaches of Webb's images? Every new observation is a challenge to our models, a reminder that the universe is not obliged to follow our expectations. Contrast this with the way science has often worked in the past. For centuries, astronomers built models based on what they could see, then used those models to predict what they would find. When Hubble revealed the expansion of the universe, it was a shock, but it fit, eventually, into a new framework. When the cosmic microwave background was discovered, it confirmed the Big Bang theory, tying together decades of speculation. But Webb's discoveries are different. They are not just filling in the gaps, they are exposing cracks in the foundation, forcing us to reconsider the very principles that underlie our understanding of the cosmos. One of the most striking examples is the so-called Hubble tension, the disagreement between different methods of measuring the universe's expansion rate. Observations of the early universe using the cosmic microwave background give one value for the Hubble constant. Measurements of nearby galaxies using supernova and variable stars give another. The difference is not small. It is significant enough to suggest that something fundamental is missing from our models. Webb's precise observations have confirmed that this tension is real, not an artifact of measurement error. The universe is expanding faster than we thought, and we don't know why. This is the beauty and the terror of science at the frontier. Every answer leads to new questions. Every discovery opens new mysteries. The scale of the universe is not just a matter of distance or size. It is a measure of our ignorance, a horizon that recedes as we approach it. Webb has shown us that the universe is bigger, older, and more complex than we ever dreamed, but it has also shown us that our journey of discovery is far from over. And yet, for all the uncertainty, there is a sense of wonder that pervades every image, every spectrum, every data point. To see a galaxy as it was 13 billion years ago is to witness the birth of structure, the dawn of light, the first steps on the path that would eventually lead to us. It is a reminder that we are part of a story that began long before we arrived, and that will continue long after we are gone. The James Webb Space Telescope's discoveries are not just rewriting textbooks, they are reshaping our sense of cosmic perspective. For generations, humanity has struggled to comprehend its place in the universe. Ancient civilizations mapped the stars and told stories about the constellations, imagining gods and monsters in the night sky. The invention of the telescope shattered those myths, revealing that the stars were suns, that the Milky Way was a galaxy, and that our galaxy was just one among billions. Each leap in technology has forced us to confront a new, larger reality, and each time, the universe has proven to be more immense and more mysterious than we ever expected. Webb's images are the latest chapter in this ongoing story. When you look at a deep field image from Webb, you are seeing not just a collection of galaxies, but a timeline of cosmic history. The nearest galaxies in the image are relatively recent, their light having traveled for a few billion years. The most distant galaxies are ancient, their light having begun its journey when the universe was still in its infancy. In a single frame, you can trace the evolution of the cosmos, from the first sparks of star formation to the grand spirals and ellipticals that dominate the modern universe. This ability to see across time as well as space is one of Webb's greatest gifts. It allows astronomers to study how galaxies change, how stars are born and die, how black holes grow and merge. It reveals the processes that shape the universe on every scale, from the smallest clusters of stars to the largest structures known, vast filaments of galaxies stretching across hundreds of millions of light years. These filaments, known as the cosmic web, are the scaffolding of the universe, the framework upon which all matter is arranged. Webb's observations have shown that this web was already taking shape when the universe was just a few billion years old, much earlier than models predicted. But the true scale of the universe is not just a matter of size or distance, it is also a matter of diversity. Every galaxy in Webb's images is unique, shaped by its own history of mergers, star formation, and interaction with its environment. Some are bright and blue, filled with young, hot stars. Others are red and quiescent, their star formation long since ended. Some are distorted by gravitational interactions, twisted into strange shapes by the pull of neighboring galaxies. Others are isolated, evolving quietly in the darkness. The variety is staggering, a testament to the creativity of nature and the endless possibilities of cosmic evolution. Webb's ability to see in infrared has also revealed a hidden universe, one that was invisible to previous telescopes. Dust, which blocks visible light, glows brightly in the infrared, allowing Webb to peer into the hearts of galaxies, to see the birth of stars and the growth of black holes. In some cases, Webb has found galaxies that appear ordinary in visible light, but are revealed in the infrared to be sites of intense activity, with supermassive black holes feeding voraciously and triggering bursts of star formation. These discoveries have forced astronomers to rethink how galaxies evolve, and how the interplay between stars, gas, dust, and black holes shapes the universe we see today. One of the most dramatic examples of this hidden universe is the discovery of runaway black holes, supermassive objects ejected from their home galaxies by gravitational interactions. Webb has observed black holes racing through space at millions of miles per hour, dragging trails of newborn stars behind them. These cosmic exiles are a reminder that the universe is not a static place, but a dynamic, ever-changing arena where even the most massive objects can be set adrift by the forces of gravity. The scale of these events is almost impossible to grasp. A single runaway black hole can weigh millions or even billions of times as much as our sun. The trail of stars it leaves behind can stretch for hundreds of thousands of light years, longer than the diameter of the Milky Way. And yet, in the vastness of the universe, these events are just tiny ripples, barely noticeable against the backdrop of trillions of galaxies and quadrillions of stars. This sense of scale, of being both insignificant and connected to something unimaginably vast, is one of the most profound gifts of astronomy. Webb's discoveries force us to confront the limits of our understanding, to accept that there are mysteries we may never solve, and to find meaning in the search itself. The universe is not just bigger than we imagine, it is bigger than we can imagine. And yet, through the lens of Webb, we are able to glimpse its true scale, to see farther and deeper than any generation before us. But perhaps the most important lesson of all is that the universe is not finished. It is still growing, still evolving, still full of surprises. Every new observation, every new discovery, is a reminder that the story of the cosmos is still being written, and that we, for a brief moment, have the privilege of being part of it. The James Webb Space Telescope's revelations have also brought into sharp focus the intricate dance between light and darkness that defines our universe. For all the brilliance of the galaxies and stars Webb observes, the vast majority of the cosmos is made up of things we cannot see: dark matter and dark energy. These invisible components shape the universe on the largest scales, dictating how galaxies form, how clusters assemble, and how the cosmic web itself is woven. Yet, despite their profound influence, they remain among the greatest mysteries in science. Webb's observations have provided new clues about these elusive forces. By mapping the distribution of galaxies across vast distances, astronomers can trace the underlying scaffolding of dark matter. The way galaxies cluster and align reveals the presence of massive, invisible halos that outweigh the visible matter by a factor of 5 or more. In some of Webb's deep field images, gravitational lensing, where the gravity of a massive object bends and magnifies the light from more distant galaxies, creates arcs and rings that act as natural telescopes, allowing us to see even farther into the past. These lensing effects are not just beautiful, they are powerful tools for measuring the amount and distribution of dark matter in the universe. But dark matter is only half the story. The other, even more mysterious component is dark energy, the force driving the accelerated expansion of the universe. Webb's ability to observe galaxies at extreme distances, and therefore at different epochs in cosmic history, allows astronomers to measure how the rate of expansion has changed over time. The results are both fascinating and perplexing. The universe is not just expanding, it is expanding faster and faster, as if some unknown energy is pushing galaxies apart with ever-increasing force. This discovery, first made in the late 1990s, has been confirmed and refined by Webb's data, but the nature of dark energy remains a profound enigma. The interplay between dark matter, dark energy, and ordinary matter is what gives the universe its structure. Without dark matter, galaxies would not have enough gravity to hold themselves together. They would fly apart as they spin. Without dark energy, the expansion of the universe might have slowed or even reversed, leading to a very different cosmic fate. The balance between these forces is delicate, and the fact that we live in an era where galaxies, stars, and planets can exist at all is a remarkable cosmic coincidence. Webb's discoveries have also highlighted the importance of cosmic time. The universe has not always looked the way it does now. In its earliest moments, it was a hot, dense soup of particles and radiation. As it expanded and cooled, matter began to clump together, forming the first atoms, then the first stars and galaxies. The cosmic microwave background, the afterglow of the Big Bang, is a snapshot of the universe when it was just 380 years old, a baby picture frozen in time. Webb allows us to see what happened next: the end of the cosmic dark ages, the ignition of the first stars, the assembly of the first galaxies, and the emergence of the structures that would eventually give rise to planets and life. This unfolding story is not just about the distant past, it is also about the future. The universe is still expanding, and according to our best models, it will continue to do so for billions, even trillions of years. Galaxies will drift farther apart, stars will burn out, and the cosmos will grow colder and darker. But for now, we live in a golden age, a time when the universe is full of light, when galaxies are abundant, and when the conditions for life are just right. Webb's images are a celebration of this moment, a record of the universe at its most vibrant and dynamic. They remind us that we are living in a special era, one that will not last forever. The stars we see today are the descendants of generations of stars that lived and died before our sun was born. The elements that make up our bodies, carbon, oxygen, iron, were forged in the hearts of ancient stars and scattered across space by supernova. We are, quite literally, made of stardust, connected to the cosmos in ways both poetic and profound. The true scale of the universe, as revealed by Webb, is not just a matter of numbers or distances. It is a story of transformation, of cycles of creation and destruction, of light emerging from darkness and returning to it again. It is a story that includes us, not as mere spectators, but as participants, beings capable of asking questions, seeking answers, and marveling at the beauty and complexity of the cosmos. As we continue to explore, to push the boundaries of knowledge, we are reminded that the universe is not just out there, beyond our reach. It is within us, in every atom, every breath, every thought. The scale of the universe is the scale of our own curiosity, our own capacity for wonder. And with each new discovery, each new image from Webb, that scale grows ever larger, ever more astonishing. The James Webb Space Telescope's journey into the depths of the cosmos is not just a scientific mission, it's a human story, one that bridges generations and cultures and unites us in a shared quest to understand where we come from and where we are going. Every image Webb sends back is the result of decades of dreaming, planning, and perseverance. It is the culmination of countless hours spent by scientists, engineers, and visionaries who dared to imagine that we could build a machine capable of peering back to the dawn of time. Their work is a testament to what humanity can achieve when we set our sights on the stars. But Webb's story is also about the power of perspective. When we look at its images, we are forced to confront the vastness of the universe and the smallness of our own existence. The galaxies Webb reveals are not just distant, they are ancient, their light having traveled for billions of years to reach us. Some of the stars in those galaxies lived and died before our planet even formed. The scale of time is as humbling as the scale of space. We are newcomers in a universe that has been evolving for nearly 14 billion years, and yet, in that immensity, there is a sense of connection. The same physical laws that govern the motion of galaxies also shape the atoms in our bodies. The same processes that forged the first stars also created the elements that make life possible. When Webb captures the light from a galaxy at the edge of the observable universe, It is capturing a piece of our own history, a chapter in the story of how the cosmos became conscious of itself. This sense of connection is not just philosophical, it is scientific. Webb's discoveries are helping to answer some of the most profound questions ever asked. How did the first galaxies form? What is the nature of dark matter and dark energy? How do black holes grow and influence their surroundings? Are we alone in the universe, or is life a common outcome of cosmic evolution? Each answer brings new questions, and each discovery opens new frontiers. One of the most exciting aspects of Webb's mission is its potential to find signs of life beyond Earth. By analyzing the atmospheres of exoplanets, planets orbiting other stars, Webb can search for the chemical fingerprints of life, oxygen, methane, water vapor, and other molecules that might indicate biological activity. Already, Webb has begun to study the atmospheres of distant worlds, detecting clouds, hazes, and even hints of complex chemistry. The search for life is just beginning, but the possibilities are tantalizing. Imagine, for a moment, what it would mean to find evidence of life on another planet. It would be the ultimate confirmation of our connection to the cosmos, a sign that we are not alone, that the universe is not just vast but also fertile. It would change our understanding of ourselves and our place in the grand scheme of things. Webb's ability to peer into the atmospheres of distant worlds is a reminder that the universe is not just a backdrop for our existence. It is a living, evolving system full of surprises and possibilities. But even if we never find life elsewhere, Webb's discoveries have already transformed our sense of what is possible. The sheer number of galaxies, the diversity of their forms, the speed with which they assembled, all of these challenge our assumptions and expand our horizons. The universe is not a static, unchanging place. It is a dynamic, creative force, constantly reinventing itself on scales both grand and minute. Webb's images are also a source of inspiration. They remind us that, for all our differences, we share a common origin and a common destiny. The atoms in our bodies were forged in the same cosmic furnaces as the stars we see in Webb's images. The questions we ask about the universe are the same questions that have driven human curiosity for millennia. In seeking to understand the cosmos, we are also seeking to understand ourselves. This quest is not without its challenges. The universe is vast, and our tools, for all their sophistication, are still limited. There are mysteries we may never solve, horizons we may never reach. But the journey itself is its own reward. Every new discovery, every new insight is a step forward, a testament to the power of curiosity, imagination, and perseverance. As we look to the future, the James Webb Space Telescope stands as a beacon of what is possible when we dare to dream big. Its discoveries will shape the course of astronomy for decades to come, inspiring new generations to look up, to ask questions, and to seek answers. The true scale of the universe, as revealed by Webb, is not just a measure of distance or time. It is a measure of our own capacity for wonder, our willingness to explore, and our ability to find meaning in the vastness of space. The James Webb Space Telescope's impact extends beyond the realm of science and into the very heart of human culture. Its images have become icons, shared across the globe, sparking conversations not just among astronomers, but among artists, philosophers, and everyday people. The awe inspired by Webb's discoveries is universal, a reminder that, no matter our background or beliefs, we all share the same sky. The telescope's golden mirrors have become a symbol of our collective curiosity, our drive to reach beyond the known, and our willingness to confront the unknown with open minds and open hearts. Webb's revelations have also reignited a old questions about the nature of existence. When we see galaxies forming just a few 100 million years after the Big Bang, we are forced to reconsider the timeline of cosmic evolution. How did complexity arise so quickly? What mechanisms allowed matter to organize itself into stars, planets, and, eventually, life? These questions are not just scientific, they are existential. They touch on the deepest mysteries of being, on the origins of order and chaos, on the interplay between chance and necessity. The contrast between the universe's vastness and our own smallness is a recurring theme in Webb's story. On one hand, the telescope reveals a cosmos so immense that our entire planet is less than a speck of dust in its expanse. On the other, it shows that even the smallest parts of the universe, atoms, molecules, living cells, are connected to the grandest structures. The same physical laws govern the dance of galaxies and the chemistry of life. The same elements that shine in distant stars course through our veins. In this way, Webb's discoveries are both humbling and empowering. They remind us that we are not the center of the universe, but we are, in a very real sense, the universe made conscious. This perspective has profound implications for how we see ourselves and our place in the cosmos. It challenges us to think beyond the boundaries of nation, culture, and era, to recognize our shared heritage as children of the stars. It invites us to approach the unknown not with fear, but with curiosity and hope. The universe, as revealed by Webb, is not a cold, indifferent void, but a place of beauty, creativity, and endless possibility. Webb's images also serve as a bridge between generations. Children who see the telescope's pictures today may be inspired to become the scientists, engineers, and explorers of tomorrow. The questions Webb raises will fuel research for decades, shaping the future of astronomy and cosmology. Its legacy will be measured not just in scientific papers, but in the dreams it inspires and the sense of wonder it rekindles. The telescope's discoveries have also sparked new collaborations across disciplines. Astrophysicists work alongside computer scientists, data analysts, and even philosophers to interpret Webb's findings. The complexity of the data requires new tools and new ways of thinking. Machine learning algorithms sift through terabytes of information, searching for patterns and anomalies. Theoretical physicists develop new models to explain the unexpected abundance of early galaxies and the rapid growth of black holes. Philosophers ponder the implications of a universe that is stranger and more dynamic than we ever imagined. This spirit of collaboration is itself a reflection of the universe's interconnectedness. Just as galaxies form clusters and filaments, so too do human beings form networks of knowledge and creativity. The discoveries made by Webb are not the product of any one individual or nation, but of a global community united by a shared sense of curiosity. In this way, the telescope is not just a scientific instrument, it is a symbol of what we can achieve when we work together, when we pool our talents and resources in pursuit of a common goal. Webb's journey is far from over. With every new observation, it pushes the boundaries of what is possible, revealing new mysteries and new frontiers. The telescope's ability to see farther and deeper than any previous instrument means that the coming years will be filled with surprises. Already, astronomers are planning new surveys, targeting unexplored regions of the sky, searching for the faintest and most distant objects. Each discovery will add another piece to the puzzle, bringing us closer to understanding the true scale and nature of the universe. But perhaps the most important lesson of all is that the universe is not static. It is a place of constant change, of birth and death, of creation and destruction. The galaxies Webb observes are not frozen in time, they are evolving, interacting, and transforming. Stars are born, live out their lives, and die in spectacular explosions, seeding the cosmos with the elements needed for new generations of stars and planets. Black holes grow and merge, shaping the structure of galaxies. Even the fabric of space itself is expanding, carrying galaxies ever farther apart. In this ever-changing universe, our own existence is both fleeting and precious. Webb's discoveries remind us that we are part of a story that began long before us and will continue long after we are gone. Our time under the stars is brief, but it is also meaningful. By seeking to understand the cosmos, we give meaning to our own lives, connecting our brief moment of consciousness to the grand sweep of cosmic history. The James Webb Space Telescope's revelations have also forced us to confront the limits of our knowledge and the boundaries of our imagination. For every answer Webb provides, it raises new questions, some that challenge the very foundations of physics and cosmology. Why are there so many massive galaxies so soon after the Big Bang? How did supermassive black holes grow so quickly, defying the limits set by our current theories? What is the true nature of dark matter and dark energy, and how do they shape the evolution of the cosmos? These are not just technical puzzles for scientists to solve. They are profound mysteries that touch on the deepest aspects of reality. One of the most striking contrasts revealed by Webb is between the universe we expected to see and the universe that actually exists. Before Webb, computer simulations predicted a slow, orderly progression from simplicity to complexity, a universe where small galaxies gradually merged to form larger ones, where black holes grew at a measured pace, and where the first stars were rare and isolated. But Webb's images tell a different story, a universe that is dynamic, chaotic, and full of surprises. Galaxies appear in abundance, already mature and massive, their stars burning bright in the cosmic dawn. Black holes are not just present, they are thriving, growing at rates that seem to break the rules. This gap between expectation and reality is not a failure of science, but a testament to its power. Science advances by confronting the unknown, by testing ideas against evidence, and by revising theories in the face of new data. Webb's discoveries are a reminder that the universe is under no obligation to conform to our models. Instead, it is our models that must adapt, evolving as our understanding deepens. This process is at the heart of scientific progress, and it is what makes the journey of discovery so exhilarating. Webb's ability to see the universe in infrared has also opened new windows into the hidden processes that shape galaxies and stars. Dust, which obscures visible light, glows in the infrared, revealing regions of intense star formation and the birthplaces of planets. In some galaxies, Webb has detected the signatures of complex organic molecules, potential building blocks of life, hinting at the possibility that the chemistry of life may be widespread throughout the cosmos. These findings blur the line between astronomy and biology, raising new questions about the origins of life and the potential for its existence beyond Earth. The telescope's observations of exoplanets are equally groundbreaking. By analyzing the light that passes through the atmospheres of distant worlds, Webb can detect the presence of water vapor, methane, carbon dioxide, and other molecules. In some cases, it can even measure the temperature and weather patterns of these alien planets. The search for habitable worlds is no longer a matter of speculation. It is a scientific endeavor, guided by data and driven by the hope that we may one day find signs of life beyond our solar system. But even as Webb brings the universe into sharper focus, it also reveals its inherent strangeness. The laws of physics, so familiar on Earth, behave in unexpected ways under the extreme conditions found near black holes, neutron stars, and the earliest moments of the cosmos. Time and space themselves are stretched and warped, creating phenomena that defy common sense. Gravitational lensing bends light into arcs and rings, allowing us to see objects that would otherwise be invisible. Quantum fluctuations in the early universe seeded the structures we see today, turning randomness into order on a cosmic scale. These discoveries challenge us to expand our minds, to embrace the unknown, and to find beauty in the complexity and unpredictability of the cosmos. They remind us that the universe is not a finished product, but a work in progress, a story still being written, with each new observation adding a new chapter. Webb's journey is also a story of resilience and perseverance. The telescope's development was marked by setbacks, delays, and moments of doubt. There were times when it seemed the project might never succeed, when technical challenges and budget overruns threatened to derail the mission. But the teams behind Webb refused to give up. They solved problems, innovated, and pushed the boundaries of what was possible. Their determination is reflected in every image the telescope sends back, a testament to the power of human ingenuity and the enduring spirit of exploration. As we look to the future, the questions raised by Webb will guide the next generation of telescopes and missions. Plans are already underway for even more powerful observatories, capable of probing the universe at higher resolutions and across a broader range of wavelengths. The discoveries made by Webb will inform the design of these instruments, shaping the questions they are built to answer. But for now, Webb stands as a milestone, a marker on the road of discovery, a reminder of how far we have come and how much farther we have to go. Its images are not just pictures, they are invitations to wonder, to question, and to dream. They challenge us to see the universe not as a collection of facts, but as a living, evolving mystery, one that we are privileged to explore. The James Webb Space Telescope's revelations have also deepened our understanding of the cosmic timeline, allowing us to trace the universe's evolution from its fiery beginnings to the intricate structures we see today. Each image Webb captures is a snapshot from a different era, a frame in the grand movie of cosmic history. By piecing together these frames, astronomers can reconstruct the sequence of events that led from the primordial chaos of the Big Bang to the rich diversity of galaxies, stars, and planets that fill the universe now. At the heart of this story is the concept of cosmic evolution, a process driven by the interplay of gravity, energy, and time. In the earliest moments after the Big Bang, the universe was a hot, dense sea of particles and radiation. As it expanded and cooled, matter began to clump together, forming the first atoms. These atoms, mostly hydrogen and helium, gathered under the pull of gravity, creating the first stars. The ignition of these stars marked the end of the cosmic dark ages and the beginning of the cosmic dawn, a time when light flooded the universe for the first time. Webb's ability to see into this era is unprecedented. Its infrared vision allows it to peer through the clouds of gas and dust that shrouded the early universe, revealing galaxies in the act of formation. Some of these galaxies are surprisingly mature, with well-developed structures and populations of stars that have already gone through multiple generations. This rapid pace of evolution challenges our models, suggesting that the processes that build galaxies and stars are more efficient and dynamic than we once believed. The telescope's observations have also shed light on the role of mergers and interactions in shaping galaxies. Webb has captured images of galaxies in the midst of collision, their shapes distorted by tidal forces, their gas clouds compressed to trigger bursts of star formation. These cosmic encounters are not rare. They are a fundamental part of galaxy evolution, driving the growth of massive galaxies and fueling the activity of supermassive black holes at their centers. The universe, as seen by Webb, is not a static collection of isolated objects, but a dynamic, interconnected web of matter and energy. One of the most profound insights from Webb's discoveries is the realization that the universe is a place of cycles. Stars are born from clouds of gas, live out their lives, and die in spectacular explosions, scattering the elements needed for new stars and planets. Black holes grow by consuming matter, shaping the evolution of their host galaxies. Even the expansion of the universe itself is a cycle, driven by the mysterious force of dark energy. These cycles of creation and destruction are the engines of cosmic evolution, transforming the universe from simplicity to complexity, from chaos to order. Webb's images also reveal the diversity of galaxies across cosmic time. Some are grand spirals, with elegant arms winding around bright cores. Others are irregular, their shapes twisted by gravitational interactions. Some are compact and dense, while others are diffuse and sprawling. This variety is a testament to the richness of cosmic evolution, to the countless paths that matter can take as it assembles into ever more complex forms. The telescope's ability to capture the faintest and most distant galaxies has also pushed the boundaries of the observable universe. Each new record, breaking discovery, each galaxy found at a higher redshift brings us closer to the moment of first light, to the birth of the very first stars. These discoveries are not just milestones. They are clues to the processes that set the stage for everything that followed. But for all the progress we have made, there are still mysteries that elude us. The nature of dark matter and dark energy remains unknown. The exact mechanisms that drive the rapid growth of black holes and the formation of massive galaxies are still being debated. The question of whether life exists elsewhere in the universe is as open as ever. Webb's discoveries have brought us closer to answers, but they have also revealed new layers of complexity, new frontiers to explore. In this sense, the true scale of the universe is not just a matter of size or distance. It is a measure of the unknown, a horizon that recedes as we approach it. Every discovery Webb makes is a step forward, but it is also a reminder of how much we have yet to learn. The universe is not a finished puzzle, but an ever-expanding mystery, inviting us to keep searching, keep questioning, and keep dreaming. Webb's journey is a testament to the power of curiosity and the human spirit. It is a story of perseverance, of overcoming obstacles and pushing the boundaries of what is possible. It is a reminder that, for all our limitations, we are capable of great things, that we can build machines that see across billions of years, that we can ask questions that reach to the edge of time, and that we can find meaning in the search itself. The James Webb Space Telescope's journey is not just about the distant past, it is also about the future. Every discovery Webb makes lays the groundwork for new questions, new missions, and new ways of seeing the universe. The telescope's success has already inspired a new generation of scientists and engineers, many of whom grew up watching the drama of its launch and deployment unfold. For them, Webb is not just a tool, but a symbol, a beacon of what is possible when humanity dares to dream beyond the horizon. As Webb continues its mission, it will be joined by other observatories, each designed to probe different aspects of the cosmos. The upcoming Nancy Grace Roman Space Telescope will survey vast swaths of the sky, searching for even more distant galaxies and mapping the distribution of dark energy. The European Space Agency's Euclid mission will study the geometry of the universe, seeking clues to the nature of dark matter and dark energy. Ground based telescopes like the Vera-C, Rubin Observatory will scan the heavens for transient events, supernova, gamma-ray bursts, and the collisions of neutron stars and black holes. Together, these instruments will create a multi-wavelength portrait of the universe, each adding its own layer of detail to the cosmic tapestry. Webb's legacy will be measured not just in the discoveries it makes, but in the questions it leaves behind. The telescope's images are already challenging our understanding of how galaxies form and evolve, how black holes grow, and how the universe itself came to be. These challenges are not obstacles, they are opportunities. They force us to refine our theories, to develop new technologies, and to think in new ways. In this sense, Webb is not just a telescope, it is a catalyst for progress, a driver of innovation, and a source of inspiration. The impact of Webb's discoveries extends far beyond the scientific community. Its images have become cultural touchstones, shared on social media, featured in art and literature, and discussed in classrooms around the world. They have sparked a renewed interest in astronomy, encouraging people of all ages to look up and wonder. For many, Webb's images are a reminder of the beauty and mystery of the universe, a source of hope in a world that can sometimes feel chaotic and uncertain. But Webb's greatest gift may be the perspective it offers. In a universe filled with trillions of galaxies, each containing billions of stars, our planet is a tiny oasis of life. The odds against our existence are staggering, and yet here we are, able to build telescopes, to ask questions, and to seek answers. Webb's discoveries remind us that we are part of something much larger than ourselves, that our lives are connected to the grand story of the cosmos. This perspective can be both humbling and empowering. It challenges us to care for our planet, to cherish the fragile web of life that has emerged on this small world. It invites us to see ourselves not as isolated individuals, but as members of a global community, united by our shared curiosity and our common origins. The atoms in our bodies were forged in the hearts of ancient stars. The light we see from distant galaxies is a message from our cosmic ancestors. In seeking to understand the universe, we are also seeking to understand ourselves. Webb's mission is a reminder that exploration is a fundamental part of what it means to be human. From the first time our ancestors looked up at the night sky, we have been driven by a desire to know what lies beyond the next hill, the next ocean, the next star. That drive has led us to build cities, to cross continents, to send probes to other planets, and now to peer back to the dawn of time itself. Each step has brought new challenges, new discoveries, and new opportunities for growth. As we look ahead, the questions raised by Webb will shape the future of astronomy and cosmology. What is the fate of the universe? Will it expand forever, or will it one day collapse back on itself? Are there other forms of life out there waiting to be discovered? What new laws of physics might we uncover as we probe deeper into the unknown? These questions are not just for scientists, they are for all of us, for anyone who has ever looked up at the stars and wondered. In the end, the true scale of the universe is not just a matter of numbers or distances. It is a reflection of our own capacity for wonder, our willingness to explore, and our ability to find meaning in the vastness of space. The James Webb Space Telescope has given us a new lens through which to see the cosmos, and in doing so, it has given us a new way to see ourselves. As the James Webb Space Telescope continues to unveil the universe's secrets, it's worth pausing to reflect on what these discoveries mean for us, not just as scientists or stargazers, but as human beings searching for purpose and connection. The images and data streaming back from Webb are more than scientific achievements. They are reminders of our shared journey, our collective curiosity, and our enduring hope that the universe is knowable, even if only in part. Webb's revelations have a way of putting our daily lives into perspective. The challenges we face on Earth, conflicts, uncertainties, the rush of modern existence, can seem overwhelming. Yet, when we look at a Webb deep field image filled with thousands of galaxies, each a universe unto itself, our problems shrink in comparison. The universe is vast, ancient, and indifferent to our struggles, but it is also the source of everything we are. The atoms in our bodies, the air we breathe, the water we drink, all were forged in the hearts of stars, scattered across space, and gathered on this small blue planet. In this sense, Webb's discoveries are not just about what is out there, but about what is within us. The telescope's ability to peer back in time, to witness the birth of stars and galaxies, is a powerful reminder that change is the only constant. The universe is not static, it is a place of transformation, of cycles of creation and destruction. Stars are born, live out their lives, and die, giving rise to new generations. Galaxies collide and merge, black holes grow and shape their surroundings, and even the fabric of space itself stretches and evolves. In this cosmic dance, we find echoes of our own lives, beginnings and endings, growth and loss, the search for meaning amid uncertainty. Webb's discoveries also invite us to embrace humility. For all our knowledge, there is so much we do not understand. The nature of dark matter and dark energy, the origins of life, the fate of the universe, these are questions that may never have final answers. But the pursuit of those answers is itself a noble endeavor. It is a testament to the human spirit, to our refusal to accept ignorance as the end of the story. Every new discovery, every new mystery, is an invitation to keep searching, to keep asking, to keep wondering. At the same time, Webb's images inspire awe. The beauty of a spiral galaxy, the delicate glow of a nebula, the intricate structure of the cosmic web, these are not just scientific phenomena, they are works of art, masterpieces painted on canvas of space and time. They remind us that the universe is not just a collection of facts, but a source of wonder and inspiration. In a world that can sometimes feel divided and uncertain, the shared experience of gazing at the stars can bring us together, reminding us of our common origins and our shared destiny. The legacy of the James Webb Space Telescope will be measured not just in scientific papers or technological advances, but in the lives it touches and the imaginations it ignites. Children who see Webb's images may be inspired to become scientists, artists, or explorers. Adults may find comfort or perspective in the telescope's revelations, a sense of belonging to something greater than themselves. Across cultures and generations, Webb's discoveries will echo, shaping the way we see the universe and our place within it. As we move forward, the questions raised by Webb will continue to guide us. What new mysteries will we uncover as we peer deeper into space and time? What surprises await us in the atmospheres of distant exoplanets, in the hearts of ancient galaxies, in the faint glow of the cosmic dawn? The journey is far from over. With each new observation, each new insight, we take another step on the path of discovery, a path that stretches from the first spark of curiosity to the farthest reaches of the cosmos. In the end, the true scale of the universe is not just a matter of distance or time. It is a reflection of our own capacity for wonder, our willingness to explore, and our ability to find meaning in the unknown. The James Webb Space Telescope has given us a new perspective on the cosmos, and in doing so, it has given us a new perspective on ourselves. We are, as Carl Sagan once said, a way for the universe to know itself. Through Webb's eyes, we glimpse the infinite, and in that glimpse, we find both humility and hope.